Hello, everyone, and welcome back from the short break. I hope you all have been enjoying the presentations today. We have just one more speaker for you, and this is going to be Barret Schloerke, who is a Shiny developer and software engineer at our studio, who in his day-to-day work develops and maintains packages for the Shiny ecosystem, including Shiny itself, Plumber, Leaflet, LearnR, Shiny Load Test. He's really one of the people behind the scenes who's making all this possible. He's going to be speaking to us today about a new package called shinytest2, testing Shiny apps with testthat. Barrett, I give the floor to you.
Perfect. I can see myself. Can I share my slides? Perfect. Great. So that's my screen. We will get to there in a minute, and I'm kind of now blind because I can't see anything else. So just wanted to make sure everything was there. Awesome. Thank you for having me. Appreciate being here. It's very exciting that there's a Shiny specific conference, not just R in general. You know, it's awesome to see. As Ian said, my name is Barret Schloerke. I'm on the Shiny team at our studio, and I'm here to talk about shinytest2. It's regression testing for Shiny applications, and we'll get into a little bit more about that throughout the talk. So let's just kind of start off like, is this talk for me? And I really hope that everyone will be testing their Shiny application. That's a wonderful, ideal world. But if you've never tested within R, there are two chapters that I would love for you to check out. One is R packages entitled Testing, appropriately. It's the R packages book down by Jenny and Hadley, and it just gives like a wonderful motivation as to why we're doing testing and what is testing for. And the second one is Mastering Shiny. The whole book is gold. Can't go wrong with it at all. But specifically the testing chapter, appropriately for shinytest2, is to how testing should be done within your Shiny application. And it just really gives like good use cases and motivation for testing those applications. On the flip side, if you're on the opposite end of the spectrum and you are familiar with shinytest and you are familiar with testthat, just kind of imagine take your shinytest code and put it inside a testthat test, and you're there. Like not too much. To have this automatically happen for you, you can call shinytest2 migrate from shinytest. And for those power users, you can off you go and have fun. You'll be in a very familiar and comfortable area. But why use shinytest2? And there's lots of reasons. And for the most part, it's pretty hard to say you can't use shinytest2 or you shouldn't use shinytest2. One of the reasons is consistent app behavior over time. I'm working with a team because communication is key, and I know I can't communicate everything that's going on inside my head. Critical features must always exist within your application, and this is related to wanting to make large code changes. So if it works before and I make code changes, does it work afterwards? I don't know. There's lots of features. You know, this is also like updating dependencies. If I go from dplyr 1 to dplyr 1.1, is that going to break anything? I don't know. And there's also too many features to remember. And manual testing may not cover all of those. And so it's really useful to have something that's automated and can run for you at any time point. Okay, so let's look at a Palmer Penguins application. You know, it's the new Hello World, but it's got a little bit more to it. Actually, we'll keep that full screen and we will just switch back. Okay, cool. All right, yes, great, we can still see. So I'm going to use this application as a demo app. It's a little cramped in here, so the sidebar is up on top, but we can kind of gloss over it and say, I have some checkboxes on the left to pick some Palmer penguins and the different species. And then I have a download button because a lot of Shiny applications, we want to download our report or data of some kind. And then in the main panel, I have a dynamic count of how many penguins are being displayed. And I also display a plot and a DT table of that information. And given what penguins I select, the plot will change and the data will change. So like there's a little bit going on, but it's a little bit more than just our typical hello world. So we can do some testing for this. Now, if I was to do some things and like alter it, there's like the really all too familiar Shiny workflow when we're doing things. And that's where like I'm going to have my working application, or hopefully working, and then I'm going to add some reactivity. I'm going to click run app or restart or do something to start that app up. And then I'm going to experiment with it in the viewer to see if it works. Click around, I unchecked a penguin species, I rechecked it, the plots changed, data changed, seems like it works. Rinse, repeat. Like, it's very effective. This is why we love R, because we can iterate every 30 seconds, iterate every 10 seconds if we want. Like, that is so powerful and it's wonderful. But I have trouble remembering what I did for dinner last week, like, or what I ate for dinner last week. I have trouble remembering, after I go to bed, what do I do the next day? And like, I was in the zone the night prior, but I may not remember everything. And I think this is like a little bit of an issue for when you're just developing all these Shiny applications. And there's a package out there that many package authors are already very familiar with, and that is testthat. And testthat is an R package that does unit testing for R. And it's a very, as they say in the README, it like tries to make testing fun. And I agree that it does. You get some wonderful emojis when you succeed all of your tests. And it also gives encouragement when you have many, many failures in a row. I had this happen while developing the package, and then now we're getting successes. And it performs formal unit testing, such as expect equal, like does true equal false? No. Or it can even do another expectation method, which is a little bit newer, called expect snapshot file. And expect snapshot file, you can give it some file contents, such as a JSON file, and then it will compare it to a known JSON file, and then it will tell you if they are identical or not. Or you can give it a PNG, like a screenshot, and then it can compare it to an existing screenshot. And then if they are bit for bit, or pixel for pixel the exact same, then life is good. We can move on. But and let's also look at some of the goals of testthat. So for testthat, if you're writing tests, almost by nature you're going to have fewer bugs. And this is just awesome because it's kind of like a double entry bookkeeping, in that I write my code and it has, I say I'm going to do this. And then we have our tests, which say, you said you're going to do this. And then they have to agree. That's great, because if I just decide to change my mind in my code, then the extra entry of the bookkeeping will say, no, you said it should do this behavior. And that's very useful and very handy to have, because you want consistent behavior over time, unless you want it to change. And then you can just update the test. Better code structure. I think some speakers this morning were talking about, I try to have things, if it's more than 50 lines, then I make a function. Just by doing that, you'll have a little bit better code structure. I like to think of it as, if I have lots of little handshakes that all say I'm doing this and I can prove it, and when I make a bigger function that uses all of these confirmed methods, then I can make a trusted actions and from these little units of testing. testthat also, like to say, it has easier restarts. And this is when I'm saying, like, I don't remember what I did last night, but what I could do is I could actually just insert a stop statement, or I could insert a failing test and then go to bed. And then when I come back in the morning, I can run my tests, I can see the failure, I can hopefully fix the failure, and then I get an achievement to start my day off. And I'm picking up running, and I'm not trying to build back up to where I was the night prior. And then finally, just the byproduct of, if you're having better code structure, fewer bugs, you're going to have robust code, because if you make sweeping code changes, you have your tests that say, you told me you're going to do these features, and then you can change the guts of your code as long as they still do the same features. And I think that's very powerful to have all four of those being achieved. So we're going to take all the wonderful things that people have been talking about with Shiny, and we're going to take testthat. We're going to combine them to make shinytest2. And this is a lot of fun because it's a package that's written entirely in R. Absalon was showing earlier today about testing in Cypress and doing things, but that involves a JavaScript side that many R developers are not familiar with. And shinytest2 is built to leverage the testthat framework for Shiny applications and not have you exposed to other libraries. Its official title now is going to be regression testing for Shiny applications. And this is where we test existing app behavior for consistency over time. So I can't really I can record that, and then I can make sure that it doesn't go away. So if you want your app behavior to be constant, this is perfect. And this is what we'd like, with regular unit formalized testing. And as I said with the recording, there's the method of record test. Record test will open up a Shiny application to capture all of the events that are happening in your Shiny application, and then it will save some code so that you can replay it at a later time. And record test, I think, should be utilized fairly often. You could almost argue per feature, there should be a recording being made. And this is kind of a different behavior from shinytest originally, in that here we're encouraging many, many little recordings to be executed. And my dad doesn't know it, but he's in my talk. And he told me when I was first learning to write on a computer, he's like, if you have time to rest, you have time to save. But I kind of want to alter it to say, if you have time to rest and think about what's going on, or you finished your feature, then you have time to record a test for your Shiny application. And I just think it's really great because I had a teammate and he's like, wow, I made a test in 30 seconds and now I know I can just leave that concept out of my brain as I move forward on my project. shinytest2 is built around the app driver object. This has many expectation methods or getter methods, and the expectations are built around expect snapshot file. Testthat's expect snapshot file. And that's because we'll be saving JSONs of the different input-output values of your Shiny application. And we'll also be looking at screenshots and saving those to make sure it's pixel perfect from iteration to iteration. And because we're using testthat expect snapshot file, we have variant support. And for the handful of users who will say, I develop on Mac and I host on a Unix system, variant is a wonderful value that you can use so that you can have different files for different variants or different operating systems or different R versions. Because most everything breaks when you switch operating systems and even when you switch R versions. So having that variant support is very powerful. And then finally, shinytest2 is built on chromote. Chromote is a headless Chrome browser, but it also allows you to view your app in a Chrome browser, even though it's headless. And because of that, we can also have our familiar debugging tools from the Chrome browser. So demo, perfect. I got more minutes than I want. This is great. Okay, all right, so Palmer Penguins, we're back here, back at it. Let's actually call record test. I was harping about record test, so I can do shinytest2 record test. Great. And oh, sorry, it wasn't in my directory of my demo. Let's do set working directory. Great. Record test, and this will open up in the Chrome browser, which is showing up over here, and so I'll bring it over there. Great. Funny. Okay, so going to ignore those special inputs. All right, so we have our Palmer Penguins. it's already set my window size to the width of this window that I'm using to record. Let's go ahead and drop the Gen2 species. Okay, set inputs was called. Awesome. I can see some updates. There's an updated value. Let's go ahead and download the CSV. Okay, I get an expect download with the download CSV button being clicked. And then let's do a expect the shiny values. I want to make sure that all of these values are going to be consistent. Okay, so I call expect values. And then let's look at the 220 Palmer penguins. If I actually, if we look in the help here, you can command click or control click on a output. And this number here is a dynamic shiny output. So I'll go ahead and click it. And then it'll say expect values output is the penguin count. So that's pretty good. I like this. I'll just say for the test name is Epsilon, and I'll go ahead and save test and exit. Then what shinytest will do is it will save those recorded tests, and it'll set up all the testing infrastructure if it doesn't exist already. And then it will run the tests so that we can make sure that our snapshot files exist, because we want as minimal amount of time from when you viewed and recorded that application and the replay. And hopefully then your replay is going to be consistent and not randomly different all the time. So we have some new download penguin CSV. We have a PNG and JSON, and let's actually look at those files. So instead of just my plain app R, I now have a tests folder. Cool. I have a testthat, which will run the testthat folder. Okay. And then the snaps for a testthat where all of those images and JSON files are stored. But let's actually look at this test shinytest2.r first. So, all right, so let's remember what we did. We started up the Epsilon, or we started up the app driver, and we had a certain height and width according to the browser window when I was recording. We then set some inputs where we took off the Gen2, but mainly we can set the selected to Adele and Chinstrap. Then we downloaded the data. We then, I think this height changed a little bit because the downloads showed up in my browser. So that's where that's from. And then we expected some values, and then we expected a particular value of the output penguin count. So awesome. It's pretty exciting. I can actually run tests, testing the file, loading up the Shiny application in the background, and then executing some of these assertions, and then awesome. All four passed, done. That actually also has, yeah, so it looked at all of these. So let's look at shinytest2. All right, so there was the download file. The download was my CSV content, so that's good. Okay, I had some JSON information, and this is actually fairly verbose. So I'll just kind of say that, you know, all of your Shiny inputs and outputs will be there. And then we actually, for shinytest2, there's a lot of discussion about screenshots, and screenshots are very, very brittle. And I just have to go over this a little bit because they're so brittle, I really discourage you from performing them. Expect screenshot, but we do provide a debug screenshot. The app looked like when I called expect values. So they're there for you to have, and you should put them in your Git repo, but maybe not have them as formal tests unless you are developing that specific section of code. Yeah. And then, oh, I am running out of time. So last thing I want to do is to just mention that there is a function called Shiny export test values. And here we can kind of think of it as a key value for the key is the name and the value is your reactives. And I can export reactives only when the app is in test mode, so it won't slow your app down for production, but you can expose your intermediate reactive values, such as penguin count, and I can say penguin count and execute it. This is invaluable, and I think not enough people use it. I just want to make sure that we can expose this, and it will be in your JSON files, like the specific counts. So I just want to make sure that we can all do that. Don't have enough time to write a test to do it, but you can check out in the slides. I have my penguins final and what it is doing there. Okay, so let's do a last little bit of presentation. Limitations, no fun slide that no one wants to see. Try limiting testing to objects that you own. So if you're taking such as a script, why I discourage them is like if you are having a base plot that's in your application, that base plot will change as your R version changes, and it's not something that you did, but things happen, and that's trying to avoid those false positives. So use Shiny export test values as much as you can. Initial snapshot files must be verified by hand. So when we make a snapshot file, all I do is I save the state. There's nothing to say that, expect equal, my count was 240. There's nothing like that. It's just, I found the count to currently be 240 for the initial, and then every follow-up must equal the prior one. So it's just good to verify those initial snapshots by hand. But if you can, write static tests or static expectations. And then, as I said earlier, minimize your calls to expect screenshot. Operating systems will definitely break your screenshots. R versions will most likely break your screenshots. Just kind of assume that if you update, your screenshots will change. And then if you're developing a package, you must install your package before testing locally. The Shiny session is run in a background R session, so there's no like locally loaded dev packages allowed. Instead, it's only what is in your public or your standard library. Whew. Okay, so I think I made it in time. If you want to screen cap something, this would be the slide to do it. I have links to the slides, shinytest2's website, getting started article, and many other articles on the website. And then for testing, please check out Mastering Shiny. The book as a whole is great, but the testing chapter, chapter 21, or our packages testing chapter.
All right, Barrett, thank you so much for that. And once again, thank you for joining us today. Just kind of looking through the chat here, we've got a couple questions. The first one that comes to my mind is it possible to test this on other browsers as well? Another way to say that is something that works in Chrome. Will that always work in Firefox? And how should a developer approach that?
So it'll only be tested in chromote because we're using or a Chromium-based browser. And for the most part, if it has, in my vast testing of Shiny applications, if it works in Chrome, most likely it works everywhere else. Chrome and Firefox are pretty, they do a good job as implementing the standard. Firefox does it to the T, but if it works in Chrome, for the most, I haven't seen a case where it like absolutely is broken somewhere else. Edge is actually using Chrome internals, so I don't think it's too far to say that if it works in Chromium-based browser, then you'll be fine.
Okay, fantastic. Thank you for that. And just really shortly, would you mind expanding upon why this change to chromote was made? As far as I know, previously it was built on Phantom.js, and if you can expand upon that in any way, that'd be great.
Yeah, two short answers. Phantom.js was end of life in 2017, so they stopped receiving updates. And personally, I think it has more quirks than Internet Explorer, and I would rather work in Internet Explorer any day than Phantom. So now that we're on Chromote, or Chrome, we can do ES6, we can run BSLib 5, or Bootstrap 5, we can do modern day things.
And it's also useful to note that if anybody's out there and wants to try a little web scraping, chromote is a fantastic tool to do that. The next question that I would have for you, Barrett, is for anybody out there who's new to testing their Shiny applications, is there ever a situation where it's not necessary to test, or do you think people should be thinking about this in a holistic way?
I think testing your Shiny application would be not necessary if it's for you and your eyes only, and for you build the app for today and you can forget about it and never have to touch it again. But if you have to come back again in 3 months, 6 months, it doesn't hurt to have a little bit of testing, or especially if you're on a team. I know I try to communicate as much as I can, and it's never going to be enough. And the test is going to give you so much more like guarantees when handing off projects or working with a team.
Yeah, there's the old phrase that if you're not just testing your Shiny applications, then you're forcing your users to do that for you. Another question that was in the chat here is...
Yes, we don't want that.
is this package can record the compile time of each web application? I'm not sure exactly what he was referring to there, but do you have any comments on that?
I don't necessarily understand the question, unfortunately.
Okay, the way that I maybe interpreted that is, are you able to put like miniature timestamps on your recording? And is that something that you're able to keep track of?
So we don't have timestamps of like when I click buttons and when I do things. But there are some built-in safety hatches. So whenever I update an input, we wait until some outputs have been updated before we move on to the next step. That way, timing issues will be very minimal. And then also there's methods like wait for idle, where I say, wait until Shiny's been idle for 500 milliseconds. Once that has occurred, we can move on. And I think it's a lot better than doing like sys-sleep in your testing code. And it's also faster because, why are we waiting around if it's unnecessary? So faster testing is always better if I can help it.
Yeah, fantastic. Yeah, thanks again, Barrett. For anybody who, maybe is familiar with shinytest, can you expand a tiny bit on what exactly the new features are, or anything that might have been missed in your presentation?
Sure. If I have 30 seconds, I'd love to share a screen and show that.
I think we've got 30 seconds.
So great. So I have penguins, and I'm going to go into my penguins final just because I have the final code that I wanted to do. And let's, so I can set up an app driver, and I have my app. And one of the things that I think is just so useful is you can call $view just like you do with your chromote. And what this will do is it will open up a Chrome browser with your app live. And if I do things like, while writing this app, I can set my inputs to just the first one, and you can see it update to the live in your other browser. That's not possible with Phantom or shinytest. And then there's just a streamlined API around knowing that we're inside testthat. And so I think the two of those is just very, very powerful.
Okay, thank you for that. We just had a really interesting question come in. Is there a way to run a test without clicking on every checkbox or every input? I.e., is there a way that we can run all the permutations of our inputs and outputs in kind of a programmatic way?
Not with shinytest2 directly, but we do talk about integrating with, David Granjon has written a nice vignette about monkey testing and integrating Gremlin.js inside shinytest2. And so he's, in his example, he uses it on a slider to where you changed all different random slider values, and hopefully you hit your permutation coverage. I think it's a neat setup and an extension to shinytest2.
Fantastic. One thing that I personally have a lot of experience in and really love this package is Shiny Load Test. And can you speak a little bit about how people can use shinytest2 with that package as well?
So I think they'll serve different purposes. So I will say shinytest2 is there to help you as a developer make sure that when you make some changes internally or you're adding new features, you're not totally breaking another part of your app, which has happened to me many times. Whereas like Shiny Load Test is more of about, did I make the right approach? Do I need to make a different approach? Can I have multiple concurrent users? And is my server setting in the right setting? So I think they have different goals overall, but with the two of them combined, you'll know exactly your thresholds of what you can do, and you'll be confident that your app will perform under pressure.
Wonderful. Thank you for that. So we got another comment here from Christian who's saying, thanks, Barrett. shinytest is one of the best things that has ever happened to me. I recall having issues trying to record some HTML widget outputs before example given IGB Shiny, or outputs that take a while to render. I would love to hear if you have seen this before and if this is something that perhaps can be accomplished using version 2.
So HTML widgets, all shinytest2 is currently recording by default, or able to record by default Shiny interactions. So like I can set an input, I can do things, but HTML widgets get in this funny area in that it's doing work in the browser that Shiny is unaware of. So I do give you some hooks like like $@ wait for JS, and you can wait until your JavaScript expression returns a truthy value, and we will wait until that happens. So my hope is that if you're writing an HTML widget, then you have enough familiarity to be able to write a JavaScript expression in there that can wait for certain things to appear. For your other comment about waiting for values to update, there's a method of wait for idle, and you can give how long it should be idle for, because it is not uncommon that Shiny makes 2 or 3 round trips where it's like idle busy, idle busy, idle busy, and then idle. And then we would say it has been milliseconds, and not the first time it just became idle.
Okay, yeah, that makes a lot of sense. This next question is maybe a little bit off topic, but what did you use to create the slides for this presentation?
Keynote. Magic Move is a wonderful little bit of flair for everything, and it's very little work.
Okay, fantastic. One thing that I personally wanted to ask you about is, in the past, I've had a lot of trouble testing Shiny modules using shinytest. And I don't know if that's a problem specific to me or if there's some sort of underlying issue there. But can you speak to that? And am I doing it wrong, or is shinytest able to help us in this way?
So yes, currently there's no way to load up a Shiny application of just your module and test just that. There are abilities that you can test your reactivity for a module, but not necessarily the UI. Shiny itself has methods to achieve this with test server, I believe, and you can point it at a module location, but it will not test your UI and click things like that. So the only way at this point with shinytest2 is to do the holistic approach, where you have to load up the full app, but maybe your actions are just directed towards that module.
Okay, yeah, thank you for that. That was possibly never mind. I think that that covers most of the questions that we have in the chat here. I don't know if there's anything else that you would like to make a comment on or anything else you'd like to say.
No, just thank you for having me. Appreciate showing off shinytest2, and I just hope that we can all write some more tests for our Shiny applications.
Well said, Barrett. Well said. Okay, well, thank you so much. And I guess we will wrap up this session right now. We'll have a couple-minute break, and then I'll be back to kind of give a small summary of the day. But Barrett, you're an amazing person, and thank you so much for the work that you're doing behind the scenes. Really appreciate it.
Thanks so much. I appreciate it.